Here we go. So today we're talking about implicit differentiation. Double check that you're all muted, please. Okay. So far we've described functions where we're looking at a y equals function, where everything on the right side of the equation only has variables in terms of x. So we have quotient rule, product rule, power rule, chain rule, all the things that we've talked about. And now we're going to talk about what happens when we have something like the equation of a circle, where the function is described in terms of two variables instead of one. Option one, we can simplify or rearrange the equation into y equals format. And then we have essentially, well, for this case, it'd be two solutions because it's a square root, right? A plus minus one. And then we can use the chain rule essentially in order to do the derivative, which is fine. It'll work. It'll be ugly. So the implicit differentiation rule is for us to do the derivative, and it will be prettier and a little bit simpler in terms of the actual derivative doing. Where it gets messy is at the end of the day, we want to isolate y prime. So doing the derivative part will be kind of simple-ish, depends on the equation. The complicated part is making sure that we are isolating y prime correctly, collecting like terms correctly, and possibly factoring if needed. Okay, so in example one, we're using the equation of a circle again, and we're going to find dy by dx. So what we're doing, I'm going to walk through it really slow. dy by dx can also be written as y prime, just as a mental note here. So what I want is d by dx, the derivative with respect to x of this function, x squared plus y squared equals d, pink pen. I'm going to try to keep consistent with my coloring here, d by dx of 25. Okay. So what we're going to do essentially is we want to take the derivative of each piece individually. D by dx, in other words, the derivative of x squared, we know how to do that. That's pretty straightforward, right? That's just 2x. Then we do plus d by dx of y squared. Now, y is a variable, but it is a function of x. So we treat this kind of like a chain rule. We need to take the derivative of y and then implicitly, knowing that it is a function of x, also take the derivative with respect to x. So what this is going to look like is 2y, right? That's the derivative of y, multiplied by y prime, because y is a function of x. So it has a y prime in there. I want you to think of it as a composition function. So you take the derivative of the outside, the y, multiply it by y prime. What is the derivative of y with respect to x? I don't know exactly what that is, so I'm just going to leave it as y prime and go over to the other side of the equation. What rule does this follow? Why is it 0? What's the rule called? Constant rule. Derivative of a constant is 0, so this is 0. So my goal is to find dy by dx, which is the same thing as y prime. So now I have the full derivative. I need to rearrange for y prime. Okay, so I'm going to move the 2x over. So 2y times y prime equals negative 2x. I'm going to divide by 2y. And this is going to leave me with y prime equals negative 2x over 2y. I absolutely can. That is my next thing. Yes. So y prime is negative x over y. Okay. Did we follow that okay? Yes. This is where it gets messy. Let's do more things with it. Yes.
Could you explain that again?
What part? Where did I lose you?
Y squared.
Back here.
Yeah.
Let me just finish this equation. Okay. This piece here is an implicit, or you can think of it as a compound function, like we did up here on the board.
Okay.
So what I'm doing, I'm going to take that highlighted piece. D by dx, y is a function of x. It is squared. So I have to take the derivative of the outside, y squared, derivative is 2y. Then I take the derivative of the inside, y prime.
How do we know that like the derivative of the inside is y prime?
Well, that's what we're looking for. Literally, that's what we're solving for. So this is dy by dx. I don't know what it is,
Okay.
right? But I know that it's a derivative because y is a function of x. It depends on x, so I know that there's something else there. The something else is what I want.
Okay.
So I'm using y prime as a placeholder to identify that is what I'm solving for.
So that's our like question mark.
That is your question mark value. Yes. So you're solving for the question mark value. All right. Next part. Find the equation of the tangent line. So this is point slope form, right? Y equals m, x minus x naught plus y naught. To the circle, here's my function f of x at the point minus 4, 3. These are my x and y naught points. My m is y prime, right? The derivative of the function is my slope. However, because I have a key point, it is the derivative evaluated at x equals negative 4, because I have a point of interest here. Okay. If m equals negative x over y, and I substitute x is negative 4, hopefully you see that the top is now positive 4. What is the bottom? How do you know it's 3?
That's the y value.
But how do you know it's the y value?
On the function.
Yeah. Yeah. Okay. I just want to make sure you know that you're not just guessing.
Okay.
Okay. So our x and y values are negative 4 and 3, so we put that in. Our point of interest, x naught, y naught, again, we know, we put that in. So what is the equation of the line? Y is 4 over 3, x plus 4 plus 3.
So this only works out because we know that the tangent is going to be negative x over y, right?
Yes.
Because otherwise, like
this is the tangent.
The point that's been given to us would be completely irrelevant, right? Because like if it was the derivative was different, right?
Right. Right. Okay. Example 2. Find dy by dx if the function is the polynomial that's right there. I'm not going to say out loud. And then find the slope of the tangent to the curve at the point 1, 2. Okay, so what I'm going to do is we're going to find general derivative first and then evaluate at the point given. Do you need to go? Yes. Okay. Things I need to notice. This is a function of x. This is x times a function of y. This is also going to give me the product rule because I have two different functions of x. I have a power of x and I have a function of x. And then this is its own function and this is a constant. Okay, the product rule is what's going to make this a little bit tricky. So let's start this nice and slow. The derivative of this function is going to be, in this part, it's just a function of x, so it's just the derivative of x. This will be 10x to the 4 plus, call this g, call this h. G is x to the 4. G prime is 4x3. H is y. H prime is 1 times y prime. Or just y prime. So this whole piece, product rule, is going to be x to the 4 times y prime plus 4x to the 3y. It is a product rule. We have two different functions of x. So we have to treat it as the product rule. So then I can take this and put it in here. So this is x to the 4 times y prime plus 4x cubed times y. My last piece is a function y that depends on x, so I use the chain rule on here, right? This is going to be 5y to the 4th times y prime equals 0, because this is a constant. Okay, did we follow how I did that? Okay, so now our goal is to isolate for y prime, which means collect like terms. I see a y prime here, and I see a y prime here. So I'm going to factor and collect those two terms together. This is going to be y prime bracket x to the 4 plus 5y to the 4 plus 10x to the 4 plus 4x to the 3y equals 0. Were you still good on this? Okay, so to isolate for y prime, that's my goal. I'm going to move these guys over and then divide by this factor. Are we comfortable if I do that in one move? Okay. Y prime equals negative 10x to the 4 minus 4x to the 3y divided by x to the 4 plus 5y to the 4. Are we okay there? Okay. I could factor the top. I could pull out a negative 2x cubed. It doesn't really help me simplify it any more or less, so I'm not going to do it. I'm just going to leave it. Oops, 4. Okay, so part A is done. That's my implicit differentiation. Now part B is find the slope of the tangent curve at the point x, so at the point 1, 2. So this is giving me an x and a y value. So I'm going to take my derivative. Y prime is negative 10x to the 4 minus 4x to the cube 3 over x to the 4 plus 5y. And now I'm going to substitute the numbers I have. Negative 10 bracket 1 to the power 4 minus 4 bracket 1 to the 3 times 2. 1 to the 4 plus 5 times 2 to the 4. I missed a little 4 there, sorry. Okay, and this is basically now a calculator question, right? The top I get negative 10 minus 8. So this is negative 18 on the top. And then 81 on the bottom. So minus 2 over 9. Worked out to be a pretty cute number after all. Okay, so the concept we have to wrap our mind around is that y is not just a variable, is a composition function that depends on x. We have to treat it as its own function as we go through.
So it's like its own thing in relation to x.
In its own thing in relation to x, that's right. Okay, can I do example 3? Are we ready? All right, let's scroll. Okay, so y prime, and again here we have a function. So let's identify the pieces. That is a regular x function. This is a composition. So I'm going to need to use a bit of a chain rule here, right? This is two separate functions, so I need the product rule here. And then this is a constant, which will just be 0 once I take the derivative. Okay, let's go. The derivative is 2x, that's our first term, plus, remember we can write square roots, oops, we can write square roots as fractions of power, right? So this is 1 over 2 y to the negative 1/2. Chain rule though, right? This is outside function times the derivative of the inside function. So there's a y prime equals derivative of the first times the second unchanged plus the first one unchanged times the derivative of the second, which is a chain rule. So you can also think of it as every time you do the derivative of y, you have to multiply it by y prime. Okay, so this was product rule and then plus 0 for the 5. So for product rule, think of this as g prime times h and then h times g prime. If I call this g and call this h, product rule. Okay, and now we are collecting like terms and essentially getting y prime on its own. I see a y prime here and I see a y prime here. I'm going to try to put them together on the left and everything else on the right. So this one and this one are going to go together. This is going to give me y prime bracket 1 over 2 root y minus x squared y squared 3 in the front y prime. Close bracket. That is my factor when I pull out the y prime. And I'm going to move everything else to the other side. So the other side already has a 2xy cubed. And I'm just going to take this term and move it to the right as well. So minus 2x. Are we comfortable there? I'm trying to go slow here. Yes.
Oh, yeah.
Oh, yes, thank you. No y prime in this bracket. Thank you, thank you. Yes, because I factored it out. Good. Okay, are we happy now? Good. Okay, so then y prime equals, I'm going to factor this. 2x, this is going to be y cubed minus 1, divided by 1 over 2 root y minus 3x squared y squared. Questions, comments, concerns? All right, next one. Okay, again, we have a product rule here. So you got to be careful when we do the derivative of that side. So it's saying find y prime for A. For B is find the tangent line at a specific point 3, 3. And then C, at what points on the curve is the tangent line horizontal? What am I looking for? What's 0? Not X. Slope M or y prime is 0. Okay, so A, find general, B, at a point, C, solve for where it's 0. This is, you'll see you have a whole page blank. This is going to take us a minute, okay? Nice and slow. Oh, my Zoom isn't working. Oh, there it is. Okay. Let's start with the derivative. Bless you. 3x squared, that's the power rule, plus 3y squared, bless you, times y prime, because this is implicit, bless you. On the other side, we have to do product rule, right? Call this G, call this H, product rule. The derivative of the first, 6, times the second one unchanged, plus the derivative of the second, y prime, times the first one unchanged. We are looking for y prime. We want to collect these two terms together, everything else on the right side. And truthfully, it doesn't matter which side. I'm just like OCD and I like everything to be something equals. I like to put this thing I'm looking for on the left. So y prime times 3y squared minus 6x. On the other side, 6y, moving this guy over, minus 3x squared. Solving for y prime. Looks like they all can be factored by 3, so I'm going to pull out the 3 here. 3y minus x squared over 3y squared minus x. And I can just erase the 3 because it factors out.
This is negative 6x, right?
Yeah, I did that whole thing wrong, didn't I? 3. 6 divided by 3 is 2. Thank you. 2y minus 3x. Nope. Thank you. X squared. Okay, 3 bracket y squared minus 2x. Okay, Ms. Gordon needs to stop doing shortcuts here. So final, I don't need the brackets really. 2y minus x squared over y squared minus 2x. There we go. So A is done. We got the derivative. Zooming back out. B is asking what is the derivative y prime at the point y equals 3, x equals 3. So we're just using substitution, right? 2 times 3 minus 3 squared over 3 squared minus 2 times 3. Don't say it's 0. It's tempting. It looks very symmetric, doesn't it? 6 minus 9 over 9 minus 6. -1, thank you. Y prime is -1 at the point 3, 3. Okay, what would be the equation of this line? Y equals negative x minus 3 plus 3. Right, because it's asking find the tangent. The tangent line is another way to say that, right? Find the tangent. Okay, are we comfortable with A and B? Okay, C is going to be a little bit tricky. We want our derivative to be 0. So let's take a look at if y prime is 0, what do we need to focus on? I need to focus on the numerator. I want the numerator to be 0. So I can simplify this to 0 equals 2y minus x squared. What do you suggest I do next? Isolate y? Okay. If I isolate y, what would I get?
Y equals x squared over 2.
X squared over 2. Good. Okay, I want to know where the derivative is 0 on the original curve. So I'm working backwards, right? In B, they gave us a point and we found the derivative. Now I'm working backwards. I know the derivative. Where is the point on the original curve? So when I work backwards, I'm going to substitute into original curve. Because then I'm going to have an equation that only has x's in it. So anywhere that I see y, I'm going to substitute x squared over 2. So looking at the original curve, I had x cubed plus y cubed, x squared over 2, all cubed, equals 6x times y, x squared over 2. Right? Whenever we do substitution, we either need 2 equations, 2 unknowns, or 1 equation, 1 unknown. We can't have more unknowns than equations. So let's sort out what can we get for x. I'm going to multiply everything by 2 and then simplify the exponent. So this will be 2x cubed plus, oh no, it's not 2x cubed. Remember when we have this is like saying cube this and cube this, right? So I got to do top and bottom. So I have to actually multiply everything by 8. Okay, so this will be 8x cubed plus 2 times 3 is x to the 6 equals, if I multiply this by 8, this makes it 4. So this is 24. X cubed. Are we happy with that? I heard a no. What are we getting stuck on? Can you tell me so I can maybe help you walk through it? Okay, so I'm getting rid of the denominator, but I have to get rid of the highest common denominator, right? This one is 2 cubed, which is 8. So I have to multiply everything by 8. Are we okay? I can move on? Okay. I can see that all of them have a factor of x cubed, so I can cancel x cubed out of everything. So this will be 8 plus x cubed equals 24. Can I factor an 8 out? No, because my middle term doesn't have a coefficient. Right, I can only factor out things that they all have. So this is x cubed. What's 24 minus 8? 16. Am I at the end of the page? Okay, I'm gonna just scoot up here. X equals cube root of 16. Is 16 a nice number? Is it a cube? What's, if we prime factor 16, this is 2 times 2 times 2 times 2. So if I pull out 3, 2 cube root 2, yes. Should it be x squared? Why do you think that? When we divide exponents, the exponents minus, not divide.
Miss Gordon,
Yes.
why are we plugging the thing into the original curve?
Because the point at which the slope is 0 is the slope of the original curve. That's why we're putting it in the original curve. I want to find, remember, think of the tree and the roller coaster guy.
Yeah.
Right? We're looking at where on the curve, where on the roller coaster does he hit the tree? So I'm not worried about the tangent. I'm using the tangent to tell me what number I need, but the point of interest is on the curve. That's why we're using the original curve equation. Yes.
Like if you move this 24 x cubed to the other side and then you take x to the cube out.
I see what you're saying. Yes, that would also work.
Then you also have like 0.
You know what? Let's do Let me back up. Let's go back here. Three, 6, 3. Let's put everything to the same side and do what you are suggesting. I would have x to the 6 minus, nope. Would it be minus? It would be 8 minus 24 minus 16 x cubed, right? So if I factor the x cubed out, I'm left with x cubed minus 16 equals 0, which gives me my first solution that x is 0. So yes, we did miss that one there. Okay, 2 options on the curve. Either x is 0 or x is 2 cube root 2. So I have 2 possibilities. I'm looking for 2 coordinates, 0 something and 2 cube root 2 something. How do I find the something? Yes, we are going to take this box that we substituted and use it. I heard a wait what? Do I need to pause? We know our x values, 0 and 2 root 2, or cube root 2. I know that y equals x squared over 2. So that means this y is going to be 0 squared over 2. So 0, 0. This one is going to be y equals 2 cube root 2 all squared over 2. This one's going to be a little ugly. I'll have 4 over 2 times 2 to the power of 2 over 3. So this is going to give me 2 cube root 4. Not the prettiest, but not the most complicated. Yes, ma'am.
Ms. Gordon, I have another question. Like you have like 0.00 that has like derivative 0, but if you substitute this point in the dx equation, like y prime equation, the derivative is undefined. So it gives you 0 over 0.
The derivative is yes and no. So because we're finding the curve on the original, we're only focused on what would make the numerator 0. So you're not wrong, but you're not right. You know what I'm saying? So we're only focused on the coordinates that satisfy the numerator 0. Yes.
I'm confused, but why are we tossing those points back into y equals x squared over 2 and 7 like the original?
You could do it in the original equation, but this is faster.
Or why, how is it possible?
Because
Okay, so because you would have to take a look at the original equation, you would have to collect like terms, rearrange for y. You have one y that's a root, one y that's cubed and one y that's 1. It would get very messy. The derivative and the original function both depend on y and x. So if you can find their relationship, the relationship is valid in either. Yeah. So you want to simplest form, right? Any further questions? Are we ready to do the last one? Dun, dun, dun. Okay, example 5. You're going to need your formula sheets. And I don't have mine on me, so I'm going to rely on you to help me with some of the trig derivatives. Oh, it's just sine and cos, should be fine. Okay, this one's yucky. There are multiple things going on. I have chain rule because I have an outside and inside function, and I have implicit. So I have like a 3-for-1 on the right. On the left, I have implicit and trig, so this is product. And this is chain. But both of them have implicit also inside. Okay, are we ready? Okay, starting on the right, when we do chain rule, we do the derivative of the outside. What is the derivative of sine? Cosine. We leave the inside unchanged. Leave it. Then we multiply it by the derivative of the inside. What's the derivative of the inside? 1 plus y prime, right? Or 1 times y prime. Okay, that's not so bad. Other side, we have product rule. So derivative of the first thing, 2y prime, right? Anytime we take a derivative of y, we have to multiply it by y prime. Times regular cos x plus the first thing, no change, times the derivative of the second thing. What's the second derivative? Negative sine x. Okay. Notice my y prime is stuck in a bracket on the right side, so I'm going to distribute the cosine. So this is going to be cos, oopsie, cos xy plus y prime cos x plus y. the bracket in the wrong spot there. There we go. Equals, can I simplify this side? Let's say 2y y prime cos x minus y squared sine x. Just makes it a little bit tidier. Okay, and then I'm gathering the y primes and everything else on the other side. So y prime bracket cosine x plus y minus 2y cos x, close bracket, equals negative y squared sine x minus cos bracket x plus y. And my final step is to divide by whatever's next to the y prime. And I guess I can factor out a negative y squared sine x plus cos xy divided by cos xy minus 2y cos x. I don't think I can simplify that anymore. None of those are trig identities. So we're done. How are we feeling? Kind of, sort of okay? Okay, I want to see some of your guys' progress and making sure that we are staying on track with what we need to know. So today you got, how long till the bell goes? Over an hour and a half. You got tons of time. No, whatever, over an hour. I want you to spend the first 20 minutes doing delta math, implicit differentiation. Take a break. And after the break, you're going to do the assignment from your workbook. Okay?
Assignment. Homework.
Like the homework assignment.